wheat in Oklahoma from beginning to end, it's Dr. Smith. If there's anyone who should be named Dr. Wheat of Oklahoma, it's Dr. Smith. Ed, we're glad you're here this evening.
Thank you, Dr. Fischer. It's a privilege for me to be here this evening and to participate with you in the Oklahoma Heritage Institute. I work quite a bit with some of the wheat farmers in the state, some of these pretty rough-talking boys. Some reminded me of some of the stories that Jim told earlier about some of these nesters and rough farmers, and that's the kind of people I work with. Generally, they're really the salt of the earth, fine people, but it's always fine, I think, if I can come down and rub shoulders with some of the finer folk like this institute, and it doesn't hurt me a bit, so I'm proud to be here. But I hope my remarks tonight are going to be slanted towards the history of wheat in Oklahoma, and the remarks will be slanted towards some of the events surrounding some of the varieties that have come and gone in the state. And I'm slanting the story this way because this is the part of it that I know best. This is my work developing wheat varieties and trying to help the farmers increase their production of wheat. And so I intend to slant the story a little bit and tie some stories into the varieties that have come and gone, but I hope to be able to convey to you some of the significant points in terms of wheat production and the history of wheat in the state. Well, so we all know what we're talking about. Wheat is a member of the grass family, and it's a cool season annual. It grows best under warm days and cool nights, and in Oklahoma it's planted in September and October and persists through the winter. It doesn't grow very much, but it stays green during the winter, and then the ripe grain is harvested in June, so it's in the ground about 8 months in Oklahoma. There's another significant thing about wheat. Wheat is unique among the cereal crops in that it has a very special type of protein in the wheat grain. This protein is called gluten, and this very special type of protein called gluten is what permits the baking of a raised or leavened loaf of bread. The gluten forms a sort of an elastic matrix which traps carbon dioxide gas when the dough is being mixed, and when the dough ferments, we put yeast into the dough to speed up this fermentation process, and during the fermentation process, carbon dioxide gas bubbles are driven off, and the gluten traps these little bubbles, and that causes the dough to fluff up and to rise, and that's why we see the small holes in the bread when it's baked. But it's this very special property in the wheat that results in this raised loaf of bread in our leavened bread, and that's why wheat is the premier among the cereal grains, because it does have the gluten that permits the baking of a raised loaf of bread. On a worldwide basis, wheat is the most important food grain in the world. It provides the staff of life for a majority of the world's population. Give us this day our daily bread is no idle plea. It has meaning to all of us, and it has special significance to many millions of peoples in underdeveloped countries who exist on the ragged edge of starvation. So wheat is important in the world. It's important in Oklahoma, as Dr. Fischer indicated. It's the leading field crop in the state. It contributes about 25% of the total agricultural value harvested or produced each year in Oklahoma. It contributes about 1/4 of the total agricultural economy of the state. It supports such industries as grain dealers and millers and bakers, and farm equipment dealers and fertilizer distributors, and even bankers are involved in the wheat industry. Another important industry that is involved with wheat, heavily involved with wheat, is the transportation industry, since traditionally about 3/4 of the wheat produced in the state is exported. Much of this goes to Houston and to the ports at Houston and New Orleans by truck and rail, and more recently now by barge through the Arkansas waterway. So a lot of the industries in the state are dependent on wheat and associated with wheat, and rise and fall with the comings and goings of the wheat farmer. In addition to the income derived by the grain production of wheat, which is something over $500 million a year the last 4 or 5 years, according to the Oklahoma Crop and Livestock Reporting Service. In addition to the value of the grain production, a number of indirect benefits are derived from wheat. These benefits are derived from wheat pastures. The young growing plants of wheat are grazed by beef cattle during the fall and winter, and it turns out that wheat pasture is a very nutritious livestock feed. The plants are high in nitrogen, and the beef cattle, the livestock that graze this, do very well on wheat. So this adds an indirect benefit. And the grazing, it turns out, the grazing during the fall and winter does not affect the subsequent grain crop that can be produced on wheat, as long as the livestock are removed from the fields before about the middle of March, when the wheat begins to send up a flowering stalk on which the grain is produced. But prior to that time, why, livestock can graze on wheat and it doesn't hurt it at all. Now, most of the wheat is produced in the western part of the state. This is because the western part of the state is the driest part of the state, and wheat is grown in the western part of the state because it is better adapted to dry conditions than almost any other crop. So this is about the only choice farmers have in the western part of the state, is to grow wheat. Also, some grain sorghum was mentioned. Grain sorghum will grow in the west, but wheat and grain sorghum and a few of the millets are about the only things that are tough enough to make it in the drier part of the state. So we see most of the wheat farms in the western part of the state. About 7 million acres of the 35 million acres in farmland are planted to wheat, and about 43,000 farm families in Oklahoma depend on wheat for their livelihood. Now, wheat farming in Oklahoma is something of a high-risk enterprise. Of that acreage planted each year, 7 million or so acres planted, in some years the farmers have to abandon 25 to 30% of the acreage of wheat because of drought or because of damage caused by insects or diseases or due to hailstorms. And farmers in the extreme western part of the state in the Panhandle say that if they can make one wheat crop every 3 years, why, that's just barely enough to get by on, and sometimes that's what they make. So wheat is rather hazardous. It's rather a hazardous enterprise, and even in good years, when production is good, as was the case in 1977, this past year, the selling price sometimes is so low that the farmers cannot make a profit. And this was the case last year, and this is the reason we see some of the farmers organizing strikes. The American Farmers Association, American Farm Movement are organizing and in an attempt to win higher prices for their wheat because of the selling price is so low. Well, enough about the importance of wheat in the state. A little bit about the history of wheat production in the state. The history of wheat production in Oklahoma begins about 100 years ago, and it begins not in Oklahoma but in southern Russia. There's a Mennonite settlement actually German Mennonites that were permitted to settle in the Ukraine 150 or 100 years before, are being persecuted by the Tsar in Russia. So in 1874, a group of Mennonite farmers immigrate from the Russian Ukraine to central Kansas, and they take with them some seeds of a type of wheat that they had been growing in Russia. They bring this seeds of this wheat with them when they come to central Kansas. This is in 1874. This type of wheat they call Turkey Red, and it's a type of Crimean winter wheat that originated around the Crimean Sea, in the Crimean area. Well, it turned out, fortunately, that Turkey Red wheat was particularly well adapted to the prairie soils of the central and southern Great Plains, and this type of wheat was well adapted to the rather harsh climatic conditions that often occur in the southern Great Plains. The extremes in temperature, the storms, the winds, and the drought that quite frequently occurs there. So the Turkey Red wheat that came out of Russia with the Mennonites certainly found a place in the southern plains, the central and southern plains, and this type of wheat, Turkey, was a prototype for our market class of hard red winter wheat that we produce now in the southern Great Plains. Now, Turkey wheat soon spread from Kansas into other states in the region, including Oklahoma. And starting in 1894, this was the first year that crop production statistics were kept by the Oklahoma Department of Agriculture. Starting in 1894, we have annual statistics regarding the production and the acreage and production of wheat. In 1894, 250,000 acres of wheat were harvested in Oklahoma for a production of 3.7 million bushels. And these 3.7 million bushels sold at an average price of 51 cents. This was in 1894, and that happened to be a pretty good year for wheat. Since then, the average production and the acreage and production have increased. In 1977, the figures were 6.5 million acres harvested for a production of 175.5 million bushels. This is a record production for wheat in Oklahoma in 1977, 175 million bushels. The price was the price in 1977, selling price for wheat was $2.35. This seems like a lot, but because of inflated operating cost, the cost of tractors and fuels, the farmers have indicated that $2.35 is below their cost of operation. It would take something like $3 or more for them to break even. So they're a little bit concerned about the low price of wheat this time. Well, getting back to turkey wheat. Turkey wheat set the stage for wheat production in Oklahoma, and it was the dominant variety in Oklahoma in these early years. In these early years, wheat was planted and harvested by horse-drawn equipment. At harvest time, the horse-drawn binder went through the wheat fields and cut the wheat and bound it in bundles. These were shocked in the field and later thrashed. Some of you will remember the old monstrous steam-driven grain separators that lumbered across the farms back in the early days. The thrashed grain was placed in burlap bags and in flatbed wagons and hauled to the barn, and the thrashing work in the early days was hot and hard and dusty. But it had also something of a festive air about it. Neighbors worked together on the farms in the community, and the women folk prepared extravagant noontime dinners for the harvest crew, and the young boys and young girls worked with the grown-ups but still found time to play and swim in the ponds and things like that. So some of us, I'm sure, have some rather fond memories of some of the early days. My time doesn't go quite back that far, but I can remember the bundle wagons and the steam-driven separators at that time. Turkey wheat, the variety Turkey, Turkey Red, and selections from Turkey held sway in Oklahoma until about 1935, when two new varieties began to take the lead. These were Black Hull and Tin Mark, and it turns out that both Black Hull and Tin Mark varieties depended on Turkey for its parentage. Turkey contributed in the parentage, entered into the parentage of both Black Hull wheat and the Tin Mark varieties, but these two varieties were improvements over Turkey in terms of production characteristics in Oklahoma. These two, Black Hull and Tin Mark, tended to dominate the Oklahoma wheat production situation until the late 1940s, when the variety Triumph came in to importance in the state. This is the wheat variety Triumph. And this is an interesting story. The development of Triumph wheat is an interesting story, and it's one, I think, of rather some consideration, some significance as far as the history of Oklahoma agriculture is concerned. Triumph was bred and developed by the late Mr. Joseph E. Daney, who farmed near El Reno, Oklahoma. Mr. Daney had very little formal education. He was a bachelor. He lived alone on his farm without electricity or running water, but he had a very keen mind and a sharp eye, and he read a great deal. He read books on genetics and plant breeding, books by Burbank and by Babcock and by Mendel and other scientists, and he knew what was involved in the breeding of new wheat varieties. And so he started his own wheat hybridization and selection program on his farm. Well, one day Mr. Daney was harvesting the plants from one of his breeding nurseries. These were individual plants spaced out so he could look at each one of them individually. They had all been derived from hybrids he had made involving different parent wheats. And one day he was looking at some of these individual plants in one of his nurseries, and he noticed a rather spindly, weak-appearing plant that had matured a week earlier than anything else in any other wheat varieties or any other wheat selections in his nursery. So, thinking it to be of no importance, he tossed it aside into the discard pile. Later that night, recalling the appearance of the plant, and we have this information written by Mr. Daney on the back of a bank envelope or a bank statement in his own hand. We have a copy of this at Stillwater, so we have his own story here with regard to how he developed Triumph wheat. But recalling the appearance of that little plant, later on that night he went back to the field and retrieved that little plant from the discard pile and saved seeds of it. And this plant is the foundation plant that gave rise to the Triumph variety of wheat. And from the late 1940s until just a few years ago, the name of Triumph was synonymous with wheat production in Oklahoma. For a number of years, Triumph was the most widely grown variety in the southern plains in Oklahoma, as well as there was significant acreage of Triumph in Kansas and Texas and Nebraska. So the farmers of Oklahoma owe a great debt of gratitude to Mr. Daney, one of our local sons. His Triumph wheat served us well and faithfully for many years. Mr. Daney died in 1959, and his records and his remaining seeds from his different experiments were bequeathed to the Oklahoma Agricultural Experiment Station, and we've been working with some of his seeds and plants at that time, and we have copies of all his documents that he had. He kept records on the scraps of paper and backs of envelopes, but he knew what he was doing in any event. But anyway, he died in 1959, and in 1967 the Oklahoma Wheat Commission presented an award in his honor. The award was accepted by his sister, Mrs. Joe Rariman of Kingfisher. In 1976, a memorial statue was dedicated. A memorial statue in his likeness was dedicated at the People's Bank in Kingfisher. And there is a Joseph Daney display case at the Chisholm Trail Museum in Kingfisher also. In 1972, I was involved with this. The Oklahoma Agricultural Experiment Station released a new variety of wheat, and we named this variety Daney in honor of Joseph Daney and to commemorate the contributions he has made to the wheat industry in Oklahoma. Well, within the past several years, a number of newer wheat varieties have begun to replace Triumph in the state. Some of these varieties are Daney and Scout and Sturdy and Tam 101 and Osage, and we have just released a couple of new wheat varieties from our program at Stillwater, so these will be coming into production. And now our wheat crop is produced with modern machinery as contrasted to the old days of horse-drawn equipment and the steam-driven separators. Our fields are plowed with large tractors, and the harvest is done by self-propelled combine harvesters which cut and separate the grain from the chaff in one operation, and trucks carry the grain off to the farm or to country elevators. And much of the grain harvested eventually passes through the terminal elevators at Enid. And if any of you have ever been to Enid, why, you've noticed those massive terminal elevators. Enid claims to be the wheat capital of the world, and it's not far wrong, because they do handle a lot of wheat through those terminal elevators at Enid. And much when the wheat gets to the terminal elevators at Enid, why, it's graded and tested and sorted and stored, and then much of it moves onto the Gulf ports for export. Well, there's one other item of historical significance, and then I want to show a few slides to end this program, but this is in regards to research. We have had research programs in agriculture in Oklahoma since the start of Oklahoma State University, and we've had research in improved wheat production methods in Oklahoma since 1892, when the Magruder wheat research plots were established at Stillwater. Professor Magruder was the first professor of agriculture at OSU, and he established some long-term fertilizer experiments with wheat in 1892. These, it turns out, are the oldest continuous wheat plots west of the Mississippi River, and there has been some discussion by our group at Stillwater to try to get some type of a historical marker for these Magruder plots. We think they have some historical significance. But this was the start of wheat research in Oklahoma with the establishment of the Magruder plots in 1892. Now, an interesting story, I was just talking with Dr. Fischer coming down here, that when Magruder set these plots out in 1892, he put them quite a ways from the main building, but by late 1940s or early 1950s, those plots were right nearly in the center of the campus, and the administrators were going to set a girls' dorm right there. Stout Hall was to be built where the Magruder plots were, so people there got busy, and they they dug a series of big trenches out on the agronomy farm, which is a mile west of the campus, and they prepared a place for these Magruder plots. There were 8 plots that had been treated with different fertilizer systems over the years, and so they wanted to maintain these 8 plots as they were. So they dug some trenches out on the agronomy farm, and then excavated the plots. They took the top soil of top 24 inches of each plot and set it aside, and then dug 4 feet of the subsoil and took that out and put it in first, and then brought the topsoil and put it back. This is moving them anyway, but we had continuous wheat on the Magruder plots, and after a few years of testing of these, we found that the performance, the wheat plants grown on these plots pretty much followed the pattern that we expected. So the transporting of the soil did not really disturb the long time results experiments very much. So this is some historical, maybe of historical interest. If I may have the slides now, I think. Well, let's see, is that got? I can set this aside. Yeah, I can take that head, or just put it down there on the. That'll be fine. You need the amplifying system. No, I don't think so.
All right.
I need that.
Oh, now you need the cord.
Where's the switch?
Oh, the switch for.
Yeah, the projector.
Oh,
The advancer.
you mean the here? Here.
Oh, I'm sorry.
We'll get it for you.
Sorry about that.
Now, this should, line, we've got enough of it there.
We've got too much.
Yeah, we got too much.
We have plenty of experts here. We already.
You have a focus on the control too.
Yeah, I've got to focus up here.
Now, are we getting it up there to you? Is this all right? Would you like the amplifying system?
No, I don't think so.
Oh, okay. Oops, that's about as far as we can move it. Now I think so.
Let's see, does that look like it's in focus all right? Look, there we go. How about that?
Now, that's right.
Okay, this is just a little map to show about wheat production in the U.S. Those are little red dots to indicate 1,000. Each dot is 1,000 acres planted, and the red is a hard red winter wheat, a type of wheat that's grown in Oklahoma and Kansas and Nebraska and eastern Colorado. This is the type of wheat we grow here, and this is the type of wheat, the characteristics of which were set by Turkey wheat. And north we have the spring wheats and the durums, and in the Pacific Northwest some of the white wheats that are used for crackers and baking of cookies, and in the east we have the eastern soft wheats also for cookies and cakes. But the bread wheats, the wheats that make the best type of bread are the hard red winters there in the red, and then the yellow, the hard red springs at the top in the Dakotas. This is a shot of a modern day wheat field being harvested with these combine separators, 6 of them moving through the field, cutting the wheat. This I wanted to point out that this is the average yield per acre in Oklahoma starting with 1895, 94, and we rocked along at about 13 bushels per acre until the late mid-1950s, and we shot up to about 20 or 21 bushels. This is a rather significant increase, and we're now up about 25 bushels, but this increase we think is a result of some of the research studies like the Magruder plots that paid off, and some newer varieties, and the widespread use of nitrogen fertilizer, which became cheap during those years, that nitrogen fertilizer became rather inexpensive and farmers began to use it more on their wheat. This is a shot of Mr. Joseph Daney just before his death, looking at some of his wheat samples there. This is one of our wheat fields, a new variety at Stillwater with a young woman standing out in it. And this is some of our research plots with my technician, George Morgan. In there, this is at the station near Enid. And here's some more of our wheat research plots where we're harvesting some of the better plots that we think will make better varieties. And here's cattle grazing on wheat. You see the green wheat makes a good pasture there and keeps cattle pretty fat. And here we're testing different strains of wheat for forage because we think we can make better types of wheat that will do a better job for livestock grazing, and so we're testing some of these with clipping operation.
Is that the Magruder plot?
No, sir, this is not the Magruder plots. Yeah, Magruder plots are back this way about a quarter of a mile from this field, but they're right here on, that's the station west of Stillwater, and the Magruder plots are on that station, but on the other side of the field. I'm sorry I didn't bring a shot of the Magruder plots. This is one of our plans for making a better variety is to increase the size of the head. On the left is the typical size of wheat that's normally grown now, or had been grown a few years ago. That's a head of Triumph wheat on the left. And on the right is a type of wheat that we've imported from, we just got a few seeds of it from Eastern Europe that has a very large head. It doesn't grow very well in Oklahoma, but we've crossed this Eastern European large-headed material with our own stuff and trying to breed a type of wheat that's adapted to Oklahoma but has a larger head than our present variety. So this is one of the ways we hope to make progress in wheat breeding. And here's another thing, the seeds on the top are also from Eastern Europe. These happen to be a strain of wheat from Romania that are about twice as large as the seeds from our standard varieties in Oklahoma, and we hope to use these in breeding to increase the seed size and hereby increase productiveness of our varieties. And here's a shot in our greenhouse. You can see we have a lot of wheat heads under these little glass bags, glycine bags. This is how we cross one variety from another. We use scissors and forceps and remove the flowering parts of the wheat, and then take pollen from another variety and place it on our prepared head, and then cover that with a plastic bag to keep other pollen out. We can make hybrids between any two varieties to combine whatever characteristics we're interested in. This used to be a field of wheat. This shot was made about a year ago near Cordell, Oklahoma. This was a green field of wheat that was practically destroyed by an aphid. That's a serious pest, the green bug. We call it green bug. This is one of our most serious production hazards, this aphid. And normally aphids are controlled by spraying insecticides by airplane like this one. Rather expensive operation. And we've about got the problem solved. This amigo over here is a strain of wheat that one of the parents of it came from Argentina, and our scientists at Stillwater had searched through about 30,000 collections of wheat from around the world, and this is the only one that is resistant to this green bug aphid. And you can see there were 2 rows of it planted and 2 rows of Triumph 64, and then the aphids were introduced into these plots, and the aphids killed the Triumph 64. All you can see is 4 white stakes out there where the rows used to be, but they didn't hurt the strain amigo. And so we're working with this thing. We should have a wheat variety available for the farmers within a few years that has the green bug resistance of amigo, so that farmers won't have to worry about losses to the green bug or spraying the expensive spray. These are some of our plans for research, increase in yield, measured using Triumph as a base. Triumph is our old standard now, and so all the other varieties have to be measured against Triumph, because Triumph's been our standard variety for quite a long time. So we are, we think, making some progress in varieties that are more productive than Triumph, and some of these have Triumph in their parentage. And this is, we hope to increase the yield potential of wheat in Oklahoma by about 50% in the next few years by 1985, and part of this we're going to do by breeding better varieties, and part of it we're going to do by managing our soil and crops a little better, fertilizer application and weed control and this type of thing. And this ends my story, and I thank you very much.
Now, do you have questions about this major industry of Oklahoma? Ed, we have a question.
Oh, I'm sorry, yes.
Yeah.
Well, I read an article several years ago by William Jennings Bryan on immortality. And he said that if you take wheat from the pyramids of Egypt that have slumbered for 3,000 years and plant it, and the spark of life is still in this wheat, he said there's no doubt in his mind about the immortality of men. Is that right with wheat that's been there 3,000 years ago?
Yes, it's there's a controversy surrounding this. I see reports on it occasionally even now, but to the best of my knowledge and based on pretty sound scientific evidence, there are grains of wheat that have been recovered from the pyramids that trace back to 3,000 years. These will not grow. The life of wheat, of a seed of wheat, is about 20 years under ideal conditions or something like that. We can keep the viability there in the grain of wheat about 20 years. I don't believe there's much to this the spark of life in the wheats that have been recovered from the pyramid. Question?
I'm curious, since the Osage country, at least as far as Oklahoma is concerned, is primarily renowned for bluegrass, how did you arrive at the terminology Osage for that one type of wheat?
Yeah, that's an interesting name. The Osage came by it's kind of a acronym for the parents that went into the variety. The Osage is a cross of Scout and Agent, and so we say Scout and Agent. That's S-A-G-E, sage, and for Oklahoma it's Osage. But you know, it's interesting. We used to historically we've named our wheat varieties in the southern plains with Indian names, after Indian tribes. There's Ponca and Pawnee and Comanche and Wichita and Tonkawa and some of these others, a lot of them. And these are very excellent names, but we're running out of good Indian names, and we have a rule that even we can't use the name twice. Even some of the varieties that were named 50 years ago and are no longer grown, they're on a list with the U.S. Department of Agriculture, and we'd like to remove that name and use it again, but they won't let us. So we have to hunt around sometimes for new names.
I might comment that about 3 years ago, the Oklahoma Heritage Association placed a historic plaque near the area where Danny's
Yes.
experiments were.
That's right, they sure did.
I'm going to guess that the lowest that a bushel of wheat went to is maybe 25 cents or less, and the highest a bushel of wheat is maybe $6 or $7.
You've hit it just about right. That's right. Between 20 cents and $6 is about over the years. Yeah.
Just out of curiosity, when did it get 20?
I don't remember the exact figure, but it was back during the Depression years sometime. I think it was about 20 or 25 cents. I've got a the statistics somewhere, but it was back in that time. And the $6 was in 1973. There wasn't much wheat sold for $6 a bushel, but that was the Kansas City price, $6 in 1973. Winter wheat, yes. Winter wheat, there's, the two wheats are a little bit different. The grain is that is produced is about the same. It can be used for the same purposes, but winter wheat is tolerant to cold, and we can plant that in October here in Oklahoma, and it survives the winter. If we plant spring wheat here in October, well, it'll freeze out. So spring wheat is planted further north, but it's grown in the summer. It's planted in April in North Dakota and Minnesota. It's planted in April and May, and is produced during the summer months.
Did I understand you all right in saying that something went wrong?
Yeah. Well,
Well, Ed,
it's about time.
may I ask a question? I'm amazed about how, through research, wheat production has gone up. Now, I didn't quite get the date. When did it take that phenomenon? I remember the graph here. About 1950.
Mid-50s, yeah.
About, in
Mid-50s.
other words, say, good solid 20 years.
Yeah.
And then now your projections to 1985. You'll increase it, you feel rather confident, by 50%.
50% over our present level.
Over the
25 bushels,
yields.
yeah.
Right, all right. Now, this is a result of taxpayers' money, and it goes into research. This is applied research, which is very important economically for the state and the nation and the world. Now, what percentage of this know-how, this knowledge you all acquire through research, comes out of the work you do right here in Oklahoma through the Agricultural Experiment Station and in your agronomy department? And what percentage of this knowledge comes from agricultural experiment stations and agronomy departments all over the United States, that, you know, as a matter of general knowledge that you funnel in here? How would you divide this?
Well, I don't know, but both sources of information are very important and very significant. I would guess that a rough estimate of 50-50 might be about right for some types of improvements that we could make. 50% are generated, of the information is generated by our own group at Stillwater, agronomy department, and other departments, and maybe 50% of it comes from findings that things that were discovered and reported in Europe or in Minnesota or California, some other station like that. So we have to keep up with what's going on in other programs. But now, as far as one example, the importance of keeping up with some of these other things was the resistance to this green bug. We searched through, we have a world collection of wheats, different 30,000 different wheat types that are, this collection is maintained in Beltsville, Maryland, U.S. Department of Agriculture. And only one of those, this thing from Argentina, was resistant, you see. So this is something that came to us from another country, but it's very critical, very important to our success of our program here and for the farmers, benefits of the farmers.
You adapt all of these, you meet the needs of wheat production in Oklahoma by applying the national, international research to Oklahoma's own unique situation.
Yeah, that's right. We have to adapt information and the systems from other countries and other states to fit our particular situation here in Oklahoma. Yes.
That I thought of is, I heard you say that the income to the people of Oklahoma is more from cattle than wheat.
Yes, sir, that's correct. Yes.
Cattle, is wheat second?
Wheat is second. Yes, sir. Yeah, last year the cattle and calf industry was valued at about $700 million, and wheat was 500 and something, so it was a ratio of 500 million to 700 million. But cattle and calves have always been the number one in the state, and wheat has been second.
Soybeans, do we have a lot of soybeans in the state?
We don't have very many soybeans, but they're a very interesting crop, and the acreage is on the increase for soybeans, yes. They grow pretty well in the river bottoms in the east, around Muskogee and eastern part of the state where we get more rainfall.
Why did the nitrogen fertilizers become cheap suddenly in the 50s?
Well, one thing is because nitrogen fertilizer is manufactured out of natural gas, and at that time we had kind of a flood of natural gas in the state, and a number of big cracking plants got into operation about that time. It's very fertilizer plants, the making of nitrogen ammonium nitrate plants. These things are very expensive to build, but several of them were constructed in the 50s after World War II, and natural gas was one of the cheapest things we had, so they became very cheap. Now, natural gas is rather expensive, and nitrogen fertilizers are much more expensive now, too. Well, thank you very much.
Well, thank you. Well, then, this in brief is the story